Today we're learning physics in the hallway. Alright, so now we're looking at Newton's third law in action-reaction forces, okay? So what we're going to do is now we have a tug-of-war between Miss Harley and myself, okay? Now, who can win the tug-of-war, Tori? Choose Mr. Harley, your point goes down. No, there's another point with this. Who can win? Choose Mr. Harley, you have less friends. Alright, now who can win? Mr. Harley. Well, here's the point. For every force, there's an equal but opposite force. So if I pull on Harley, she pulls on?
Pull back?
Yeah, pull. Who's pulling harder? Who's pulling harder?
You are moving.
Who's pulling harder? I thought every force, there's an equal but opposite. You can't pull harder. How do you win the tug of war?
Let me pull it.
You can't pull harder. You think you can pull harder than me? You think you're better than physics?
Am I slippery?
For every force, there's an equal but opposite force. You can't pull harder than me. You can't. The laws of science say you can't. So how am I winning? Or if Bryce comes over here, how can he beat me?
You pull.
Yeah, you do.
I mean, I was just.
How did we make this
I don't
look?
even know if I was
Okay.
pulling. I was just holding it.
Listen, what if I pull off one of your fingers? How coach gonna feel when you try to go? You're gonna be out there against Jeff Davis with one finger missing. Okay. Alright. Now we're going to get on this little cart right here. We're going to do the same tug of war. Now don't you pull any harder. Now you just pull and you just. Oh my goodness. What's happening now? How'd you win the tug of war? You didn't pull harder. Reduce the friction. So you don't have to pull on Mr. Harn harder than Mr. Harn pulls on you. You got to pull with more force than the friction. What are you pulling against? You're not pulling against Mr. Harn. You're really pulling against the friction of Mr. Harn. Remember when we talked about external forces, right? The forces acting on me are Bryce is pulling on Mr. Harn and friction is pulling on Mr. Harn. Mr. Harn's pulling on Bryce, but we don't include that force. Yes, because my force against Bryce and Bryce's force against Mr. Harn, this force right here cancels each other. But the force of friction is low. So what happens to Bryce's force now? It's greater than the force of friction. Why were we able to make Chandler move on the air track or the? It reduced the friction. Okay. So if we remove this thing, how are you going to win now? Now you got to pull with more force than there is friction. So for every force, there's an equal but opposite force. Yep. The problem is, if that's true, then objects do not accelerate. Every object is either stays the same speed or is at rest. Well, we obviously know that isn't true. So what's happening? You're pulling greater than another. You don't pull greater than Mr. Harn pulls. You pull with more force than there is friction. So like when Bryce sat down and he did like this, I mean, this is a good way to increase the resistance. But you also don't have very much surface area on the ground.
Yeah.
Now I sit like this, you might have a little more force now. Now what thing control friction? Well, that's in another chapter. For now, Newton's first law says an object at rest remains at rest in motion or in a straight line. Newton's second law says if there is a force, the object will accelerate. But Newton's third law says for every force there's an equal and opposite force, which means things don't accelerate except it's his force, not against Mr. Harn's force, but against another force, like the force of friction. So we have to take that into consideration. Okay?